In the next session, we'll understand the role of technology in this domain. We have a presentation by Sujeet Gohil, Sales Director, Energy Division, ABB India, on the topic Leveraging Technology for the Smart and Sustainable Growth of City Gas Distribution Networks.
Hello everyone and a very good afternoon to all of you. My name is Sujeet Gohil and I am from ABB India Limited. I would begin this session with a moment on safety by wishing best of health and safety to you, your family, friends and colleagues in the current times, and also request to maintain all the social distancing precautions and continue to be safe. Indeed, we had a very enriching and insightful panel discussions by the industry leaders on infrastructure development for city gas distribution. Now, taking a cue from various topics discussed by the esteemed panel, in this presentation, I would touch upon the technology aspects in the CGD for boosting efficiency and profitability by leveraging technology for smart and sustainable growth of rapidly expanding city gas distribution networks. Let us have a quick look on the major components, or should I say, the building blocks of city gas distribution infrastructure. The first one is the main receiving station. We call it as a city gate station, followed by regulating and metering stations. Now, through a complex pipeline network, the regulated gas is then distributed to the CNG stations, industrial consumers, and domestic connections across the given geographical area. So, what are the major challenges? A typical geographical area is widely distributed. Hence, firstly, it calls for a meticulous planning to consider both the present and the future demand. And along with that planning, the infrastructure needs to continually facilitate the last mile connectivity as the network keeps on expanding. Now, the next point is maintaining the requisite flow and pressure in the growing network while keeping a strict vigil on the inventory and pilferage control is a no lesser challenge either. Another very important factor is the ability of centralized price control and management. Now, since the CGD prices are subject to frequent changes, and this would not be possible to achieve without a strong operational layer through which, with minimum intervention, price change can be administered across the entire network. And with ever expanding CGD networks, the selection of right level of automation to eliminate manual intervention so that the CGD companies can achieve more with less is also a very critical point. Let's look at the CGD infrastructure layer. Measurement, control, remote telemetry, and communication are the four pillars for building a resilient infrastructure layer. Gas flow measurement is achieved through flow meters and flow computers, whereas the gas chromatograph measures the gas quality. Add to this, transmitters, detectors, control valves, and the leak detection system ensures that the operation continues to remain safe and reliable. After having achieved the measurement and the control layer, the next vital thing would be to have a real-time transmission of the field data to a centralized place. So once the complete measurement has been done, then RTUs or data concentrators or programmable logic controller, through an appropriate communication protocol, through an appropriate communication media, which would be the best suited communication choice for the given geography, that would ensure that the measurements are transmitted in real time. Now, having realized a strong backbone at the ground level, which was the measurement, control, and the transmission layer, the next important thing is to select the right operational technology. That is supervisory control and data acquisition system, which we all popularly refer to as SCADA. From our experience, we can say that execution of this very step often determines the strength and robustness of the CGD operational layer. And hence, in this slide, we will dive into the most important aspects that should be considered while selecting the operational layer, which is SCADA. Firstly, for CGD, often the need is to have an ability to start small and expand with time. Hence, scalability is one of the most important factors for technology selection, such that the high performance real-time database management system would continue to effectively handle the growing needs of a gas network without any limitation whatsoever. So the idea is that you should be able to start with a smaller footprint and then continue to increase the footprint as the consumers, the network, and the spread in the geographical area increases. Next, the SCADA system should also be able to provide the flexibility of architecture, that is ranging from a simple architecture to a high availability fault tolerant architecture with the ability of disaster recovery. The architecture should be such that in case of multiple failures also, the robustness or the availability of the system should not be impacted. Taking it to the next level, the architecture should offer the CGD operating company a choice whether to have an on-premise based solution or a cloud-based solution, and both the solutions with the same level of cyber secure design. The next important point that we have here is the graphical user interface, or as we call it as a GUI. Fundamentally, the GUI should make the operator feel at ease to make the right decision at the right time, and also offer the option of mobility in the SCADA, which would ensure the continuity of operations while the operator is on the move. By design, the SCADA should be able to communicate on a very low bandwidth as well. That's because there will be instances or there will be geographical areas where the communication bandwidth will not be uniform across. So fundamentally, the SCADA or the operational layer should have the capability of communicating as efficiently as in a high bandwidth environment as in a low bandwidth situation. And it is also recommended that for the CGD operations, there should be a gas reconciliation module so that the entire gas inflow and outflow can be reconciled, and that can help the CGD operator to plug the gaps of pilferage, of theft, whatever it may be. And now, since we all know that the number of third-party equipments which we'll be having at the CGD operational layer would be varied. So the SCADA system should also have a richness of third-party interface. Multitude of protocols should be protected and without any limitation whatsoever. The very important point here is also about selecting the SCADA system, which is with the latest operating system, since it will enable a longer life cycle and it will support the very cause of operating a CGD with a very low operational expenses. Selecting something which is latest would ensure that the overall OPEX cost is optimized, and hence the selection of the operational layer is one of the most important and a key contributing factor in the CGD operations. Now, after having established a state-of-art operational layer, in the current times when things are becoming open, it is very vital that the platform that we have chosen is also cyber secured with adequate prevention mechanisms, which can range from, say, system hardening, robust password policies, user management, role-based access controls, maintaining the audit trails and security log, and the list goes on up to whitelisting of the IPs to ensure that only the whitelisted users have the access, thus preventing any non-certified or non-authorized user from accessing the SCADA system. It is also important that the SCADA operational layer should be designed in accordance to IEC 62443 standards and recommendations thereof. Now, having established cyber secure and a state-of-art operational layer, the next thing which the CGD company would want to have is a seamless bidirectional transfer of data between the SCADA system and the chosen ERP platform. And why it is important is because bidirectional interface between the SCADA system and the ERP would ensure that there is no manual intervention, there is no manual logging, and hence there is no manipulation or a room for manual error. So with this bidirectional transfer, the data integrity would be ensured, and it will also introduce complete transparency from field to the boardroom. Last but not the least, let's also make the life of the operator or the person who is operating or managing or monitoring the command control center as comfortable as possible. Well, there are various choices that we have today of going for multitude of screens with large display walls, which are very difficult to maintain, or we are having some ornamental solutions which offer very poor collaboration. However, the need of the hour and what we have seen from our experience as all the customers are adopting is to have an environment which is listed on the, which is stated on the rightmost side of this slide, which will promote the sense of collaboration, which will have all the information available to the operator on a single click. An operator will not be required to figure out information looking at various monitors or various screens, so much so that even your live video feed, the GIS, all of them can be integrated at a single place. Now, with a strong base and the backbone in the field, which is complemented by the right selection of futuristic SCADA solution, digitalization is only a step away. We, in fact, with all of these now have an Industry 4.0 ready platform to implement mobility for ease of operations, to have on-the-go data availability for actions, dashboards to monitor gas bought, gas sold, utilization pattern which can help decipher how the utilization changes across consumers, seasons, and all of that possibility is now made open. This will also open up a possibility of artificial intelligence and a forecasting mechanism that would continually adapt based on the building, the database which will now start building upon with time. And that rich database that we'll have will open up possibilities, operational efficiency. And now if we club GIS integration along with this, it will add the feature of accurate identification of assets, their management, having video feeds of any such assets or any such operational requirement that we can actually think of. The whole point is that once we have a robust layer at the bottom, the possibilities then are unlimited. One interesting topic which I would like to touch upon here is drone-based leak detection system. We all know and we do realize how important it is to identify the leak and arrest it in the shortest possible time for continued safe operations, for the overall safety and also the overall reputation. The drone-based leak detection system with an inbuilt gas detector will not only improve on the response time, it will also improve on the accuracy, it will also make the whole process faster. And if this is mapped with the GIS, it will facilitate the accurate identification of leak location with the longitude and the latitude. Now we'll have a look onto a few case studies here. The first such case study is on Assam Gas Company Limited. The challenges that the company faced was on the ability to optimize the gas flow and ensure that the contracted volume is delivered to the user at the given flow and pressure. And this was achieved by implementing a strong measurement and control layer in the field, comprising of instrumentation, control, RTU, and a customized telecom solution to overcome bandwidth challenges. Now, with this strong backbone, the data was then made available for centralized control and monitoring, along with gas reconciliation. The offered solution is also completely scalable to cater to the multifold increase of users across the state of Upper Assam. Next case study, which I would like to share here, is on the SCADA system that was initially deployed for only a very few locations. However, in a span of few years, it has grown multifold, encompassing a very, very vast geographical area and efficiently catering to the expanding network, both of stations and the users. This is not only a true example of SCADA system that can be deployed with a very small footprint and then expanded with time with practically no limitation on scalability. Also here it is important to mention that the feature of centralized price deployment is utilized by the CGD company on a very regular basis in its day-to-day operations. The last case study which I would like to share here is on the SCADA-based solution for another city where the challenges were slightly different. The challenges were on the confidence level, the challenges were on whether a SCADA will work or not, the challenge was on whether we'll be able to select a right partner for solution or not. Now, here in this case, it so happened that assessing the capabilities of automation partner is a very crucial step that determines the success of technology being deployed for the operational layer. And to ascertain the same, in this very case, the approach was adopted that a proof of concept demonstration should be done in the bidding stage itself, and the results of that were made a part of evaluation. This approach certainly ascertains the right selection of the technology partner. Summarizing the session now, selecting right technology in the field and that for the operational layer, it does enable the CGD company to choose a platform that is scalable, provides accurate control and monitoring, permits centralized price control and billing. And this operational platform should be futuristic, should be Industry 4.0 ready, such that the rich data bank is utilized for digitally enabled decision making, with all the information from field seamlessly flowing to the command center and from there to the boardroom. All this can be achieved with a reliable, with experienced and a well-qualified automation OEM as a partner for the profitable growth. With this, I would like to end my session. Thank you very much for your time, and please feel free to reach out to us should you have any queries. Thank you.
Thank you, Mr. Gohil, for the precise presentation. Stay tuned and keep tweeting using the hashtag ETEnergyCGD.